This is House Planning Help episode 274. Hi there, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Matt Barnett Howland from CSK Architects. Not only has he built the world's first load-bearing Cork House, but it's ready for the end of the life cycle, having been designed with disassembly in mind. Just before we launch into our interview, I wanted to commend Matt for allowing so many people to go and take a look at the house. It's just one of those things that I noticed, hold on, they've got a very good setup here, including a presentation in their kitchen all about the house. And clearly they've taken a lot of people around. I wasn't the only one that day. And I know from having shown people around my own home that it does take a lot of time, a lot of energy as well. So it's just such an important part of learning, isn't it? And I discovered this fact too. If you heard the previous episode to this with Paloma Gormley, all about the flat house, well, she came to visit the Cork House. And not only that, there's going to be a return visit so that Matt is going to go up and see the flat house in Cambridgeshire. So brilliant. Just remember, it doesn't just have to be building professionals. If you get that invite to check out any building, really, you're going to learn something. So let's get to our featured interview with Matt Barnett Howland. We haven't talked a massive amount about the end of life cycle. Maybe we think that buildings will be around forever. But I pose this question. When was the last time you went past a building that was being demolished? And I can think this morning for me as I was taking my daughter into nursery. And I mean, it was a huge site as well, just an absolute mess there. So could we not try a little bit harder? I think so. And part of this solution is interesting too, because it involves a great material, that being cork. So let's find out about that, and of course the design and the build story too, as we always do. I started by asking Matt to tell me a little bit about his background.
I am Director of Research and Development at CSK Architects on the High Street here in Eton. I was educated at Cambridge, followed by the Bartlett, and always been interested in making things as well as designing things. And after sort of working for various architectural practices, in 2013 decided I wanted to undertake this project. So I, together with industry and academic partners, put together a research team and spent the next 5 or 6 years developing the solid cork construction kit, as we call it, and the Cork House, which is the first pilot for that construction kit.
I'm assuming cork must have come first. You must have had a love for it or an interest or an intrigue.
No, cork strangely didn't really come first. It came shortly after the main driver, which was probably a slightly grumpy dissatisfaction with what we typically build with, especially in sort of modern house construction here in the UK. And, you know, I've designed and built many buildings using this type of construction where it's a very layered form of construction using a whole range of products and materials and systems that make this very complex assembly. And when you actually analyze what you end up with in one of those constructions, it's not a particularly attractive prospect in a number of ways, and most importantly for me, introduces complexity across almost every stage of the building's life cycle. You know, right from the sort of resource stage and landscape impacts through to even the design stage, specifying different materials and with different properties and so on, through to on-site sequencing of trades, interfacing between trades, through to the performance gap that you almost always get in houses where they always perform less well than they're predicted, right through, and particularly, most importantly, probably to the end-of-life scenario where you have a destructive demolition. And so that's one of the main motivations behind the project also, was a sort of idea of designing a building with respect to its material ecology, and not designing a building and then thinking about its material ecology, thinking about the material ecology and then developing an architecture out of that, if you see what I mean, it's reversing that idea slightly.
I was just going to say that can be one of the challenges, is you start focusing on one area and it dictates the others.
Typically, yes. Yeah, typically, as most people, the process of designing and making buildings is quite a sort of granular process, by which I mean, you might start with a client has a site that has particular characteristics you need to respond to, and then they will have a brief. So you develop a design, and then that's got to go through planning, and then the planners might have certain ideas about what they want to look like externally, and the client probably has some ideas what they want to look like internally. And then the engineer gets involved in terms of what the structure's made of, and then you want to make a construction that passes building regulations, and then it goes through the pricing process and some value engineering, should we say. And before you know it, you have this thing that sure enough works and ticks all the boxes, but the way you've got there is not through a very holistic approach. And that's what this project allowed me to do, unusually, I guess, as the client, initiator, researcher, designer, and in the end builder as well. It allowed a sort of single-minded and a holistic approach to the project.
So I'm still intrigued a little bit about this research side of things. So you've gone through a number of different aspects of the project, but what came first?
Yeah, obviously there's a whole aspect to the building which is a response to specific characteristics of the site and what we wanted to achieve with the building and so on, which I can talk about if you want.
Yeah, we want as much detail as possible, so yeah.
At the back of our existing house, there's two gardens that sort of go down to a bottleneck between them next to the riverbank, a slightly awkward junction and geometry. We weren't really using this most rear garden that much. And so we placed the house in such a way to create a sort of house and garden setup in this rear garden, but also the end bay of the house creates a threshold space between the two gardens that sort of articulates that junction between the two, and is an antechamber to the house itself, and is also an outdoor living space for the house. So it was very specifically sited and designed in that respect.
So what was on the brief for this project?
So the brief was driven by that dissatisfaction with the complex wall that I was describing. So we had the idea, or the question, if you like, or the thesis, could we make a building envelope, walls and roof, out of a single biorenewable material to fulfill all the functions of the modern building envelope still to modern performance requirements. So that, in a way, became the brief. Could we develop this solid cork building envelope? And that's where the research kicked in. So with that concept in mind, I applied for research to Innovate UK and EPSRC. And that's when we put together this team of industry and academic partners. And between us, over 2.5 years, we tested and prototyped and developed the proof of concept for this solid cork building envelope. And then the house is the first sort of pilot application of that new system that we had researched and developed.
I think before we get ahead of ourselves, just a bit of background on cork. Where does it come from?
Cork comes from the Mediterranean rim. I think roughly 50% of the world's cork is produced by Portugal, and we worked in this project with the cork supplier called Amarim, who are the world's biggest cork manufacturer and supplier. It's the bark of the cork oak tree. It's called the Quercus suber, and it's called suber relates to the unusual material that's in the cork that gives it its funny combination of characteristics, which is called suberin. Most of the value from the cork harvest is used for obviously cork stoppers, wine stoppers. And then there's a whole agglomerated cork industry, which is granulated cork mixed with polyurethane glue to make a whole range of industrial, technical, furniture products and so on. But then, in a way, the waste from the forestry and from those previous industries, they end up in what's called the expanded cork industry, which is a very important distinction in that the cork is granulated, put into large fixed volume ovens, if you like, saucepans, and it's cooked at a very high temperature, about 360 degrees centigrade, with dry steam passed through it. Under this heat and steam, the granules expand, and they also release a natural resin inside the cork the suberin, which then melts, and then as it cools, it rebonds the expanded granules of cork back together again. So blocks of expanded cork that we've used throughout this project is in fact a 100% pure, biorenewable and biodegradable product.
And why do they sometimes do something differently? It would seem natural, as with many things in life, whatever the material is, but why are they adding other things to it?
Oh, so typically if there's something like what they call agglomerated white cork, which is, say, if you buy a coaster from cork coaster from IKEA, that's typically agglomerated cork. It's sort of beige coloured stuff, and the reason you would introduce polyurethane binders into that is for performance reasons. You can make it then very thin, it's hard wearing, it's an industrial performance product in a way. This expanded cork is a slightly more rougher agricultural process. Obviously in terms of impact isn't quite as good, and in terms of other mechanical properties, but it was adequate for what we required, and more importantly had this purity that was very important to the life cycle considerations of using it in the building.
So how have you considered that life cycle? Let's say it gets to the end of life of this building. Do you anticipate it could go straight into another building?
First of all, it's important to say that just because the house is designed with an awareness of the fact that it at some point in the future may come to the end of its useful life, I'm not looking to hasten that moment.
Quite understandably.
It's like timber buildings. If they're detailed well and looked after, then they should be able to last for, why not several hundreds of years, as you will find all around Scandinavia. So having said that, yes, I still think that buildings often do come to the end of their useful life, or people need to get rid of buildings for redevelopment or for whatever reason. Anyway, I think that it's important to consider the end of life scenario. I don't want to make out that they're consumables, as it were, in the same way that maybe a plastic knife and fork are. But nonetheless, I think it's important to consider that as part of the building life cycle. And so we designed this entire house without any mortar or glue between the cork blocks. All the timber elements, connections between them are bolted and screwed, whether that's the windows into the cork, or the beams to the structural wardrobes, or the floorboards to the solid CLT timber floor, which are screwed. Everything is accessible and demountable. And that obviously then makes it easy in terms of recovering materials or elements of the construction, either for reuse, if possible, or if not for reuse, then for recycling back into the manufacturing chain. And failing those two options, then of course the cork, being pure cork, can actually be granulated and go straight into the soil to biodegrade and generate new growth, which in fact is one of the uses of granulated expanded cork. Already is used as an aerating soil improver.
Well, I know there are many benefits. So the obvious one that I know is about insulation, but what else? What can you tell us about the benefits of cork?
I think the benefits of cork in this instance are that it enabled that initial primary objective. In other words, its unique range of properties means that it could fulfill all the roles of a building envelope that are normally fulfilled by a range of different materials. So, in other words, structure, rain tightness, air tightness, insulation, internal finish, external finish, the enclosure that it gives you, and so on. That's all done by the cork in this instance. That's the way in which that was the benefit of the cork, if you like, is the range of applications it allowed.
So getting to this stage, it was obviously a research project. What else did you need to find out about it before you started building?
So we did a range of tests on prototypes that we made, smaller constructions, the cork casket, which is like a sort of dog kennel almost, and then a slightly larger cork cabin with the two main prototypes. And we tested those sort of in situ, if you like, on site in terms of weather. We had them tested for air tightness, and they're obviously very useful in terms of the construction process. They taught us a lot about that as well, and obviously lots of little bits and pieces where they gave us feedback on what we were trying to achieve. And as well as the tests on the prototypes, we also undertook a range of lab tests as well. For example, we tested wind-driven rain at the BRE. We did some fire tests for the roof classification at BRE. University of Bath, Pete Walker at University of Bath. They're the sort of, in a way, the leading national researchers in terms of bio-renewable materials in construction. They tested for compression, creep, shear. They tested the system for outer plane loads, all sorts of interesting structural tests that characterized the material, which then Arup, the engineers, were able to extrapolate for the design of the house, as it were.
Yeah, tell us about that then. You've mentioned that cork is a structural material, but then is that what has informed the building and how it's developed?
Yes, the architecture, the spaces and the forms are a result of the properties of the material, of the consideration of each stage of the building's life cycle. So, for example, the pyramidal corbelled roofs, we didn't draw pyramidal roofs at the start and then think, what should we make them out of? Let's try cork. The pyramids come out of a whole series of decisions about deciding to use cork. It works best in compression. We don't want to use glue and mortar for disassembly reasons. And the wall works with the tongue and groove system, so a logical consequence of that is for the roof is, rather than introducing a new set of materials and systems that would introduce complexity, is that you offset this wall system using these solid blocks of cork to take the load through them. And so the form is a result of those considerations and those factors.
And what's the challenge then on site? Did it all work? You're doing this. I love that expression.
Well, it is, obviously, it's the first load-bearing cork house in the world, as far as we're aware. So I guess for any system with that level of innovation built into it, it's obviously not going to be always a good day on site.
Was it easier for just, building up to roof heights, and then when you're dealing with that roof, that to me looks the tricky part. You've made it look very neat, though, I will say that.
So obviously the foundations are removable steel screw piles, and there's no cement whatsoever in the building.
Yeah, tell me about this, because I've heard this a few times. People say that this is sustainable because you can take it out and use it again afterwards. Was that the full...
No, probably the motivation was more that when you did take the building down, took it away, that it would become virgin site again almost. You wouldn't have known there'd even been a building there, which obviously you can't do with huge amounts of concrete piles or foundations. So there's
a bit more cost involved in that, having screw piles? Or
I don't think there was much more cost involved in that necessarily. I mean, probably a little bit in terms of, say, doing a simple strip or raft foundation, yes. But not a lot, not that made it prohibitive. And again, it was on message with the narrative. It was a dry form of construction. Subcontractor came on site, 2 days on site, foundations done, which ended up with little steel discs on the surface of the ground. And then you put your little sort of 200 millimeter high steel feet on top of that, bolt down to that, and then steel T-brackets bolt onto the top of that foot. And then this Koya ring beam spans from foot to foot. That makes a nice, big, simple 300 by 100 timber beam all the way around the perimeter. And then with a contractor assisting us, we dropped large CLT floor plates that spanned between that ring beam. That gave us a nice, solid timber deck with cork insulation underneath the timber to insulate it. And then from that point, I guess was a nice, easy bit in that the cork blocks are literally, you pick one up, you put it on top of the previous block, it friction fits down, you tap it to make sure it's gone home, as it were, with a rubber mallet, and then you do the next one. You tap that down, and then it literally goes at about the speed I'm describing it, and then the next one, and so on. So that was very swift in terms of building the walls. Where it's not so easy is where it interfaces with the timber ring beam and valley beams, which are at eaves level. So all the cork works in pure compression and takes all vertical load. All the vertical load in this house is taken down to the slab, the timber slab, via the cork. Almost all of the lateral load and shear loads of the house, to stop it sort of folding over, as it were, in the wind, is taken through this timber ladder beam, almost like a ladder beam if you drew it at eaves level. And that ladder beam is tied down in two places to these structural wardrobes, literally structural timber wardrobes, and that stops the whole building fall over. Anyway, the point being that the interface between the prefabricated timber elements and the prefabricated cork elements, there was, as you can imagine, at that level, when you're trying to get the cork into a certain shape so that you can fit the cork together, so you can fit the timber together and screw it and bolt it, that took some effort. There's a very funny photograph of me trying to sort of ratchet strap and clamp in an 18-metre long wall of cork into exactly the right shape so that the timber at eaves level fits in, and that was complicated. The roof, actually pretty satisfying, strangely. A lot of block types and so on, and a reasonable amount of filliness like that. But actually, generally speaking, bar 1 or 2 days, quite good fun. The gutter, weirdly, I made a massive mistake. I don't know if this is of any interest. With the gutter, I've built in the gutter into this sort of layered construction system, because that's what the whole thing is. It's characterised in a sense by one thing on top of another. It's really primitive in that sense. It goes back to structures thousands of years old. These sort of really simple dry stone wall and roof constructions. You still see them in the south of Italy, or the beehive huts in Scotland and Ireland, or lots of cultures have the similar archetype. So although it's quite a high-tech fabrication process for the house in terms of prefabricating the cork and the timber, it's actually a very low-tech on-site assembly process. That's really important to me. In terms of self-build, I find an immense satisfaction in something, in just making anything, really. So, for example, we've often referred to this as a sort of giant organic Lego, and it's that same idea. There isn't a massive amount of skill necessarily in how you put these elements together, but you still get that satisfaction of having built your own house out of a kit of parts.
How have you prefabricated this then? Where does it happen?
It's prefabricated by a company called Wapdoodle in Suffolk, who used a 5-axis CNC machine, but pretty simple form of technology, really, just using a milling cutter or 2 or 3 different cutters on an automatic tool changer, and it literally just, one face of the block sits on a vacuum bed, is held in place, and that allows the other 5 faces of the block to be machined so that they fit together with a sort of zero tolerance friction fit on site.
And these actual connections, they're a technical design that you drew up and wanted for this?
It's not dissimilar to timber log cabins, They're sort of engineered products and engineered systems that fit together with a sort of interference fit, tongue and groove idea. I mean, it's a variation on that theme, if you like. It's just these are quite nice because they're 1 metre long by ½ metre wide by about 20 centimetres high. They're about 12.5, 13 kilograms each for a full-size block. So manhandleable by a single person on their own, and you can just literally build it like a giant form of Lego.
How are you finding time for all of this?
So it was pretty much full-time for about 5 or 6 years.
Full-time?
Mm-hmm.
Oh, wow.
Yeah.
And the construction time?
Construction time, if I compressed it all into a sort of single on-site operation like you might do on the 3rd or 4th time you did it with a contractor, it would probably be about a year of work. It was 2 of us on site for a year in total if I added up all the time between us, yeah.
But you had to slot this into your professional life. So
no.
Oh, no, okay.
No, it was full time for 5 years. Yeah.
Wow. Okay.
No, my dad was an architect. We started designing this together when he was dying, and he left us some money, and we thought a good thing to do with that money was to, because although obviously this dual motivation of this project, or maybe more than 2, one is to obviously build a house that we can use ourselves, but also there is obviously an element of research and development and using our skills in terms of design research to respond to some of the pressing issues of our time.
What do you think he would have made of the building had he seen it?
Yeah, he was pretty competitive and pretty critical generally. Yeah, no, but he would have liked it. Yeah, no, he would. Yeah, obviously, it's probably inevitable that there's quite a lot of him in this building. Probably in that there's a lot of him architecturally in me, and
How did he influence you as an architect?
Well, the main way in which we communicated as father and son over the last 25 years, I think it would be fair to say, would be through architecture.
Very interesting.
Yeah, which may be the case for lots of sons of rather obsessed architects. Yeah, so that's where we connected, and so this was a nice thing to work on with him. And he's always been a slightly do-it-yourself sort of person as well. In that, likes to sort of, if he thinks he can get away with doing a job himself, he'll probably have a go. And I guess there's a bit of that going on. Yeah.
What did you learn from doing this project?
Aside from the obvious, that I learned how to build the world's first solid cork construction system, I enjoyed the process of learning about the research, really, the way in which you go about these things in terms of conceiving and developing an idea, putting together a team, getting the funding, the lab tests, the prototypes, getting it through building control, how a building design / system takes on its a life of its own, and you have to systematize it, and it becomes more and more rigorous as you go on. That'd be something that I'd be really interested in taking forward. So some of the principles to do with the life cycle stuff I was talking about, I mean, we are taking this forward on another cork project with a client at the moment, but aside from more cork, it would be nice to look at the same issues, life cycle issues, maybe through other materials, low carbon materials, obviously timber, but also obviously stones, a very interesting one on that front.
Just talking about the performance then, so with all this cork stacking up, and there's literally nothing between these blocks other than how they're connected sometimes, do you feel any drafts? Have you had an air tightness test? Or
we had an air tightness test, that was fine. We were mid-range on that. So two things we had to introduce back into the uber simplicity of the cork wall and roof. So on the walls, we had to introduce a rebate on the internal face of the blocks, joints, and introduce a 10 millimeter wide foam tape to achieve air tightness. It'd be nice to find a way of doing that without using a foam-based product, obviously, in the future. And on the roof, we found that we had to introduce cedar weatherboarding to help shed the rain off the roof. Otherwise, the roof is not watertight, just as a pure cork structure.
And what about around the windows? How are they sealed?
Yeah, those are also sealed with contraband foam tape. Again, that allows, I mean, obviously, as I said, it'd be nice to find other methods of doing that, but it's quite interesting what it allows. If you want to take the house down or the window out, you literally take out 6 bolts out of each window that you knock, literally just the window slides out, the sticky back foam tape peels off, and it's simple as that.
And the cork itself, was it easy to get hold of this much cork? Because I'm imagining this might be quite a big order, or not?
It's a couple of shipping containers of cork. It comes from Portugal, shipped to Harwich, which is near to the workshop in Suffolk. They machine it, and because of the way it was done as a sort of gradual project, this one, they would ship it in sort of 40 to 50 blocks at a time, and there were 1,268 in total.
And other materials in this house, I can see you've used timber in the kitchen, and I know there's another section for the bathroom, but what other materials exist in the house?
So we tried to be pretty rigorous and consistent as we went through the various parts of the house, from the primary structure through to the built-in joinery, which is tri-ply or tilly board, and it's spruce, so it's the same as the CLT species, and then we made all the bed and the sofa and the dining table out of reclaimed spruce CLT, 44 millimeters thick. And we had the kitchen stools are made by a craftsman in Sussex called Bobby Handcrafted. And he makes these lovely oak stools out of storm-felled oak. And the floorboards are also oak, of course, because cork is a variation on an oak tree. Floorboards are cross-sawn, unplaned timber screwed down to the spruce CLT floor. So we can see there's a sort of very limited, consistent palette of materials. And the only place where we wandered a bit, if you like, or introduced some light relief was in the bathroom and the kitchen. So in the kitchen, worktops are 5mm thick solid brass, unlacquered, and the same for the bath was a bespoke folded solid brass bath, as was the basin. And there's and copper for the rainwater goods, gutters, downpipes, and so on. So both brass and copper, all unlacquered, all pure material, and can all be recycled back into the manufacturing chain.
One thing I have noticed in here is that the services are slightly interesting, including, are they sprinklers?
Yes. So obviously when you're making solid walls with no voids or cavities or any surfaces to hide behind, everything is exposed and on show, right down to the sprinkler pipework, sprinkler heads, or even, how do you get a cable up to the top of the roof light for the motorized roof lights and smoke detectors up there. So that was all very carefully thought through. And the bathroom is a self-contained, independent, solid CLT box structure, which acts as this sort of hub for all the surfaces. And then the CLT floor panels were pre-routed to accommodate pipe runs underneath the floorboards. And all the built-in furniture and the structural wardrobes are also pre-routed for service routes and so on. And then where it came out, where the pipework comes out into the pyramids, that was a really enjoyable working with the subby on that. Because obviously we did have subcontractors for the electrics and the plumbing and the sprinkler system, in fact. And that was nice working with those guys, in terms of they're obviously they're really interested, but they're doing something different. They'd never worked on a solid cork house before, as hadn't I. Just coming up with solutions between us, and mocking things up, and that was great fun.
Well, then finally, what does this all mean in your career? And you've mentioned you're hoping to move from the main house out here fairly soon. So how does this building fit in?
Yeah, I guess obviously it's scratched a pretty major itch. And I guess, it's obviously clarified my overall approach to architecture. We're now lecturing at various big offices in London and at various universities around the country with a lecture called Form Follows Life Cycle. And we're looking, we do that in a discursive way. So we're sort of looking to sort of evolve and develop this approach, more broadly speaking, both with cork and with other materials, as I said.
Well, Matt, thank you very much for telling us all about the house today. It's great.
Pleasure.
Get more online at houseplanninghelp.com/274, where you can review the key points once again. We always provide a summary laden with photos. I think a lot of photos on this because there's some very nice photos. So you can check out the whole construction process, have a look at the site, some of the plans as well. If you've got a comment or you'd like to ask a question, scroll down to the bottom of the show notes, or we're all on social media. We'll put the links into the show notes as well. Linking to Matt, linking to CSK Architects, houseplanninghelp.com/274. Finally, if you're in the early stages of your project, carrying out research, trying to get your head around what is an ecologically sound house, well, we want to help you out here, and we've done quite a few interviews. Perhaps we've done too many interviews and you're just getting overloaded. Well, what we have done is put together a free e-course that tries to take you to the key messages, I suppose. That's what we've done, not to overwhelm you. We've obviously made a lot of podcasts. We've also made some videos. So we want to try and lay out a path for you. If you'd like to sign up to that free 10-day e-course, it's easy to do. Just head to houseplanninghelp.com/tips. Next time, serial self-builder David Snell returns to the podcast to explain how he keeps a tight rein on costs. Are you worried about costs? Well, yeah, it's a hard one, but I'm interested to see what you make of next time. He always comes up with the goods, loads of great information. I hope you can be with us next time. The House Planning Help podcast is produced by Regen Media, content that matters.